Good morning, doctor. My name is Samuel Ng.
My name is Guan Young.
My name is Terence Su.
And we are from Section 1. And today we're going to present about our group project, which is on solar street lighting system. So this is the table of contents for our presentation today. The first part we're going to talk about is our project scope and plan. The second part is the objectives and expected benefits of our project. The third part is the technical details of the project. The fourth part is implementation steps. The fifth part is covering the NPV and SPP, which is the methodology. And the final part, which we will discuss on the potential challenges of our project. Okay, so now I'm going to talk about our project scope and plan. So our project is mainly focused on rural areas in Malaysia. Because rural areas, they tend to have limited access to energy sources, and due to their extreme geographical location, it is difficult for them to be connected to the national grid for electricity. So these areas have a high reliance on diesel generators for electricity. And because of that, these rural areas also lack basic infrastructure such as street lighting. And if conventional streetlights were to be installed in this area, these streetlights will then need power and electricity from the diesel generators, which will contribute to more carbon emissions, which is bad for the environment. So our group proposes a solution that is to install an off-grid solar streetlight system in the area so that it utilizes renewable energy to illuminate rural areas while reducing carbon emission and provide a sustainable and cost-effective alternative for rural communities instead of using conventional streetlights. So the second part is about the objectives and expected benefits of our project. So the objective of our project is mainly to install off-grid solar streetlights in rural areas in Malaysia. This project aims to improve energy accessibility and efficiency in off-grid locations such as rural areas, as we mentioned. So it will reduce environmental and financial impact while aligning with Malaysia's commitment to the United Nations Sustainable Development Goals (SDGs), particularly the SDG 7, SDG 11, and SDG 13. And moving on to the expected benefits of our project. So the installation of solar power streetlights in rural Malaysia offers several key benefits, as you can see here. The first one is environmental impact, because this project will significantly reduce the carbon emission by utilizing renewable solar energy instead of fossil fuels, contributing to climate action goals. And the second part is economic saving, because it can lower operational and maintenance costs due to the grid independence of solar streetlights, providing long-term financial benefits for rural communities. And the third one is enhanced safety for the local residents in rural areas, because this project will let them have a reliable lighting that improves public safety, reduces accidents, and deters criminal activities during nighttime. And last but not least is the energy accessibility in these areas. This project provides consistent lighting in areas with unreliable or no grid connection at all, bridging the infrastructure gap between rural and urban regions. So now I will pass to my friend to continue on the third part, which is the technical details.
Now I will be talking about the technical details for our group project. The technical details, which is the solar power streetlights, will operate independently of the grid while reduce reliance on diesel generator, as the solar power streetlight absorb the solar energy from the sun and generate electricity, and this will minimize greenhouse gas emissions and provide reliable lighting for rural areas while aligned with efforts to combat climate change. Now, this is the specifications for the streetlight. The first column will be the diesel generator power streetlight, and the second column will be the solar streetlight. Next, I will be talking about the comparison between streetlight powered by diesel generators and solar streetlights. So, The street light powered by a diesel generator, the power source is come from diesel, while the solar street light, the power source is come from solar energy. The operating cost for street light powered by diesel generator is very high, while there is no recurring cost for solar street light. Next will be the maintenance cost. So, street light powered by a diesel generator requiring a regular bulb and wiring checks, while for solar street light require for battery replacements for several years. And the diesel generators to power the street light will cause carbon emission, while there will be no carbon emission for the solar street light. Next will be the installation complexity. The street light powered by the diesel generator requiring direct cabling, while the solar street light will be independent from grid electricity. Next, I'll be talking about the implementation steps. So generally, the system component will require a 60 ampere hour per 25.6 voltage battery and a 60 watt with type 2 light distributions for even coverage of LED lights, and the brightness required a 10,505 lumens. The installation plan will be first we need to identify the locations where the village with flat terrains and minimal tree coverage for optimal solar efficiency, and the coverage for the solar street light will be within 1 kilometer road with 40 solar street light spaced 25 meters apart, and the pole height for the solar street light will be 6 meters. Next, by considering the energy and operations of the solar street light, since Malaysia have an average of 6 hours of sunlight per day, that will ensure sufficient charging so that the solar street lighting will operate from 7 p.m. to 7 a.m. There will be a dimming system in the solar street lighting, where for the first 4 hours will be 100% brightness. The solar street light will dim to 16% brightness for the next 2 hours, and the last 6 hours will dim until 40% of its brightness. Next will be the installation steps. First is the preparations. We need to construct the concrete foundations for stability of the solar street lights, and we need to install the poles securely in the prepared foundations. Next is the optimizations. After we have installed the solar street light, we need to adjust the solar panels angle for maximum sunlight captures and ensure the panels are free from shading. The important components like batteries, controllers, and wiring are protected in a jewelry box to shield them from weather, UV radiations, and thieves. The last step will be the system testing and monitoring. We need to verify the system, whether it will generate electricity during the day and provide reliable lighting at night. We can also conduct a pilot run, monitor performance, and make any necessary adjustments. For the methodology part, I will pass to my other team members.
Now I will be presenting about our methodology, which is the net present value and simple payment. So here is general information about our methodology. So the village is using a 125 kilowatts generator to fulfill the needs of 200 village houses. So to ensure adequate lighting and visibility, 40 units of street light will be installed along a 1 kilometer stretch of road, so that to ensure uniform coverage and prevent dark spots on the road. So here are the estimation for the consumption of diesel by a 125 kilowatts generator depending on the load. So from this table we can calculate the amount of diesel needed per day in liters, which in total which is 140.8 liters. Next, this is a table that shows the lifespan of components of the solar street lights. So for the lithium battery, it has a lifespan of 5 years. Solar controller has a lifespan of 20 years, and the solar panels have a lifespan of 25 years, and LED light have 11 years of lifespan. So the price for each unit of the lithium battery is 700 ringgit, and the price for the maintenance of LED light for each unit of LED light is 300 ringgit. So the diesel price is 2 ringgit and 98 cents per liter according to the latest fuel price during 2nd of January to 8th of January in 2025. And the consumption of 1 liter of diesel will emit around 2.7 kg of carbon dioxide, and the carbon tax per kilogram of CO2 is 0.00817 ringgit. So our initial cost will be 180,000 ringgit. And next we will calculate the diesel cost for a year, which is the total is 151,050 ringgit and 24 cents. And the social cost for carbon is per year is 1,180 and 13 cents. And the total profit per year will be 152,168 ringgit and 37 cents. So there will be a maintenance cost for the lithium battery for every 5, 10 and 15 years, and there is a LED light maintenance for during the 11 years. So we can calculate our net present value, which is around 1.4 million ringgit, and our simple payback will be around 1.18 years, which is less than the lifetime of our project. Next, potential challenges. So one of the main potential challenges is theft and vandalism, because in rural areas the possibility of happening robbery is much higher, and so by solving this problem we can have a tamper-proof design and raising community awareness and partnering with local authorities to monitor the installations to prevent theft. Next, we also encounter energy storage challenges, because during cloudy or rainy periods, disruption sunlight may lead to inadequate battery charging. So the solution to address this problem is advanced battery technologies with high storage capacities or backup system. The last one is transportation and installation. Transporting and installing solar street light in remote rural areas may be logistically challenging. So collaboration with local authorities and detailed planning are necessary to streamline the installation process.
That's all from us. Thank you.
Good morning, Doctor. My name is Roger.
My name is Terrence.
My name is Samuel Ng.
We are from Section 1, and today we are going to demonstrate our project, which is on the topic of green energy innovation for a sustainable Malaysia.
So our group's project scope is focused on rural areas in Malaysia. So because of their extreme geographical location, it is unfeasible and difficult for these areas to be connected to the national grid for electricity. So these areas often rely on diesel motor generators for electricity, And rural areas in Malaysia also often lack basic infrastructures such as streetlights. So this will endanger the local residents living there, especially during night time. And if conventional streetlights were to be installed in this area, they would need to rely on the diesel motors for electricity, which will produce more CO2 gas into the atmosphere, which is bad for the environment. So our group proposes to build an off-grid solar street lighting system in the area so that it can reduce carbon emission, because the off-grid solar system does not need to rely on motor generators for electricity, and by that they can also provide safe street lighting for local residents, especially during night time.
So basically, how does this solar street light work? So when during the day, the solar panel will absorb the solar energy from the sun, and this solar panel will then convert the solar energy into electricity. The generated electricity will then store inside the battery, which is buried under the ground. When during the night, the battery will discharge the electricity and supply to the LED light during the night.
So the switch will be the demonstration for light sensor. So during the night, the light sensor will detect reduced light in the surrounding. So it will automatically light up the LED light and enabling them to function and light up independently without the national grid. So the light distribution is evenly spaced and it can light up the road, so accident can be prevented and robbery can also be prevented, which ensure the safety of the residents. So that's all from our group. Thank you.